I'm going to put on recording and we will start. Okay, so today we will do another case study. It's about TMDB, a movie database, okay. And there's a lot of detailed description about this case study. And on our course website, you should also be able to find the CSV file. So the first is like what we already learned before. You always get the CSV file, and we can get a glimpse of the file, what it looks like. So here, if you take a look, you will find, okay, this is regarding some movie databases. This has ID, and this specific movie database ID, and the popularity, budget, revenue, title, cast, homepage, director, tagline, and runtime genre, and the vote, count, release date. You can see, so quite a lot of information. That totally, there are 21 columns. Okay, so 21 features for this movie database. And if we want to know a little bit more about the column information, and if they are null, and you can do the data frames, data info, okay. And from the data info, we can see totally they have over 10,000 entries. Okay, and then to give the column information, that for like ID, okay, totally how many null values, that, and the total, it's this is consistent with the number of entries, records, is it? But if you take a look like cast, so cast non-null values, its number is not the same as the total entries. So that tells us there are some null values that for the cast column. And then if you take a look like a homepage column, then for homepage column, there are quite a number of null values. Is it for the homepage? It's far more than the non-null values, okay? And the director, we can also see there are some. Is it a tagline? And so over here, we can also find some information regarding the null values. That because if you want to do some analysis or do some calculation, null values will have some impact. Is it? And over here, it also tells a total memory usage for this data frame. Okay, so we kind of have some idea. Is it? So the author said some columns, is it, has quite a number of null values. Is it like a homepage, tagline, keywords, and the production? Is it said especially homepage and tagline? Is it? And also depends on what kind of analysis you want to conduct. Is it? And this case study try to analyze some popularity trend. So this looks like the homepage tagline will not contribute the analysis. So then you can drop some of the columns. You don't need to keep all the column. Okay, and generally speaking, for the data, normally you also want to get some statistic, basic statistic summarization. So you can call the describe function. And over here, it tells us like the total number of entries, mean value, standard deviation for like a popularity or budget or something. But if you take a look, the minimum 25 quantile, 50 quantile percent, or 75, and the maximum value is it. If you take a look at the budget and the revenue, you will find some interesting thing over here. For minimum 25% quantile, even to 50% quantile, did you see? There are a lot of zeros. Okay, so generally speaking, that doesn't make a lot of sense, is it? Especially if we want to do some analysis regarding budget to revenue and how it impacts like the popularity or some other analysis. This doesn't make a lot of sense, is it? So why that can be caused, is it? So over here, the author said, so it's kind of, oh, and also over here, one more column I forgot to mention, like the author said, okay. And regarding the popularity, it seems similar. If popular for this percentage of quantile, etc. And if you take a close look for the data of the range, you can also find it's not even the same scale, etc. From 75% it's 0 points, and then jump maximum to 32. Is it so? It's kind of, we say there are outliers. Is it in popularity data? Is it? And then the author said to try to investigate, is it? And it says, according to the forum, the popularity score is measured by what? The number of favorites and the number of watched list and some other factors. Is it? So, and also it doesn't have upper bound. Okay, so that's what, so sometimes when you do analysis regarding some topic, then maybe you need to do some further analysis, is it? Because you need to determine if you're going to keep the outliers or not, is it? So the author, after the investigation, the author said, the author decided to retain the original data. Okay, and also like what I previously explained, is it like a budget and a revenue? There are just too many zeros in budget and revenue. Okay, and it says also runtime. Is it? Then you need to ask about the data. Is it? Because collected data may not 100% precise. Is it? Then you, so the data analysis also counts on the data reliability. Is it? So why? Then you may ask why you can have those kind of not common or common sense things. Is it? Is it because a movie never be released? Is it? But they also said regarding the release year column, the author did find of the movies released. Is it? Did find. So then the author said just assume that zero values is due to the missing data. Okay, so for data analysis, a lot of you also need to deal with the missing data. Okay, missing data. But it says under the risk that this zero values, it all may be just not large enough. Is it not larger? So the author said also needed to take a look for the zero data content so that the author can decide if it's missing or some other reasons. Is it? So that's regarding, so when you have the data set, then you, for some kind of not outliers or not common sense, then you need to raise some question, okay? So how do we find, like, get some more detailed look about zero budget and revenue data, etc. And over here, you can do filtering, etc. So you just find if budget is zero, then you have them go to this data frame, is it? And here you can get like the first 3 entries or record to take a look. So here to give the 3 of the zero budget once, is it? So then you may do some further investigation, is it? And then what next also try to show is you want to find totally how many of those zero budget. Is it zero budget? So you can use the data count. Then it tells us totally it has over 5,000 records. Okay, that has zero for the budget. Okay. And then it says the author then did some further analysis. It says among the zero budget records, the author just randomly chose some movies, is it, and want to investigate what's going on, is it? And the author said did find some information regarding the budget. And basically that specific movie does have budget record. Okay, does have. And the author said also find similar result for the revenue in this specific data set. Okay, so it does have those movies do have budget, do have revenue. Is it? So the author said can further confirm the data is because of missing. Is it because of missing? And because of the missing data, the author said probably can drop some of them or set them as null values. Okay. And the author said, because the author want to include those quantification number in the data set, etc. And it's going to impact some statistic and also visualization, etc. So you need to decide if you want to drop those missing data or reset as null values. Okay. So that's what the further analysis based on those zero budget and zero revenue, okay? And what the next one try to show us is do the group by, okay? And this time it's group by the budget and then it's going to try to show the ID, okay, show ID, and then do the count, okay, do the count. And then it gets the top 5 record. Okay, top 5. So you can see for the zero budget, it has over 5,000, etc. So we over here try to get, you can also use group by, okay, to do something. Okay, and then over here, it shows the result for that group by, etc. And then show the number of that specific budget, etc. How many you have for that specific budget. And here it gave us some detailed information, okay. And then the author said we already saw it, is that there are over 5,000 records for the zero budget, the zero budget. And the author said, in case if they dropped too many raw data, is it? So the author said going to retain those rows and replace zero with null values, because that's quite a lot, over 5,000. The total is just over 10,000 something, is it? So it's already kind of half of if you drop. That's probably going to impact some analysis and also data integrity. So that's going to retain those zero budget values. Okay, so that's what the author tried to do. And then similar thing for the revenue, okay, for the revenue column, okay. Also do group by the revenue and then do revenue count. And then you can also see it's quite a lot. It's almost 50% of the raw data, they have zero revenue or zero budget, is it? Okay, and then what the next one try to show is for the runtime. Okay, and then for runtime, you can see not a lot of zeros. Okay, and because not a lot of zero for runtime, the author said going just to drop that. Okay, so that's this part is just help us you decide which you want to drop. Okay. And then so all of the previous analysis is regarding data cleaning, is it? So before you do some further analysis, we want to do some data cleaning, okay? Especially like for model building, you do need to have data cleaning, okay? So first, the author said drop unnecessary columns. Is it like a homepage tagline, like those unrelated IDs? Those they can drop, and also duplicate. The author also plan to drop. Okay. And also the author said drop null value columns, but be careful just with a small quantity of nulls. Okay, not a large one like a cast, director, or generals. And for zero values in budget and revenue, just replace with null values. Okay, and for runtime, if it's zero, then just going to drop. Okay, so that's the decision. Okay, and once you decide what you are going to do for the data cleaning, as a drop or replace, then the first the author going to drop the unnecessary columns. You see, how do we do that? So what the author did is put off the column name in a list. Then you just call data frame the drop and plug in with that list. And of course, you need to specify which axis and if it is on the original data. Okay, because if you don't have in place as true, it will not happen on the original, it will just give you a copy. Okay, so here it is. And then you can call the head and then do find some information, is it? Okay, and then the second part is we are going to drop duplicate. So you can call data frames drop duplicate and also make sure it's in place is true, okay, so that it will on the original data. And then the next part is drop NA, is it? Still do drop. And here the subset is regarding what? Is regarding those three columns, is it? And with what? It's a how or all or whatever, as it here says any, okay, and also in place. And after that, you can do some checking, is it? And here is, you can check, okay, the null values, is it? And do call the summation, is it? Then you can find, okay, now after the cleaning, looks like only keyword and production company, they still have null values of the others already taken care of, okay. And then what next, if you recall, previously the author decided for budget and revenue, the zero entry is going to be replaced with snap value. It's, the author decided not going to drop that. Okay, so just replace them. So after this, you can get the information of the data frame. So let's take a look. And if you recall, the original has 10,886 entries, is it? And now if you take a look, so it's less than that. So that means did drop some null values, is it? But if you take a look, the budget revenues, they are still kind of just half of the original, is it? Because we fill with all of the zero with null values, is it? And the keyword and the production company, they still have some null values, is it? So that's the information regarding the data, okay. And then what next? You can double check, is it if the runtime 0 column already be totally cleaned, and then you can do the query. You find, yeah, it did get cleaned, is it? So that's regarding this part. So some verification, okay. And after that, you just do the information to confirm, is everything kind of getting close to what you expected, okay. Okay, and then at this point, you can do the data frame statistic, the summary result again, so called describe, is it? And after we call the describe, and if we take a look further regarding budget and revenue, if you take a look regarding previously regarding minimum 25 quantile percentage and 50 quantile percentage, they have some issues, is it? Now, if you take a look, they got some, it's kind of based on the data, kind of makes some sense now. It's not all 0, is it? Yes, so we did make some progress, okay, regarding our data cleaning. Okay, so generally speaking, you can see for data analysis, the first step is step 1 is data cleaning. Data cleaning, generally speaking, regarding the research, is it? And then after that data cleaning, we move to step 2, is it? Step 2, then you can do EDA. You will see this EDA a lot in data analysis. So it's what it represents, exploratory data analysis. Okay, so we are going to do some exploration, is it, regarding our data so that we can find some trend. Okay, and for this research, the author said the first part is going to do some general exploration. The general exploration, the first regarding movie popularity over of the years. Then the second question, they also want to find the distribution of popularity regarding revenue levels, but only in recent 5 years. Same thing for the distribution of score rating in revenue levels, also in just recent 5 years. So that's what the author plan to do, the general exploration. Okay, so let's see. So the first is regarding popularity over the years. Okay, we want to find how you can make your movie popular, etc. So the author get the data and take the first 2 entries, etc. So just try to get some glimpse of the information of the data. Okay, and then the author said, the author planned to calculate the mean of the popularity for each year, and then do some plotting to find the trend. Okay, to find the trend. Also, the author said popularity doesn't have upper bound, is it? Upper bound. So then it may affected by the outlier. Is it? And because of the author said also not just completely based on mean value for the popularity, also calculate the median value, okay, for the popularity, okay. So over here, you first do group by regarding release year, okay, release year. And then you find the mean, so for the popularity, is it? And here is the latest 5 years, is it? Popularity, this data information. So this is regarding year, okay? And it's on mean, and you can also find the media, okay, regarding group by year, okay, the mean value, okay, of popularity. And you can find, if you compare mean and median, it's offset, is it? A little bit. And then the next, because a lot of time visualization helps a lot, is it to find the trend, okay? See, so we try to do some plotting, okay? So the plotting is regarding the mean value and the median value of the popularity, etc. So we also want to know the index, okay. Okay, and then for the plotting, over here, they also pick the C-bar, okay, plotting. And for the C-bar plotting, for this case, then you need to pick X, Y value, etc. So X value is going to be the index. The index is like year, etc. And the Y value is going to be the mean, and the second Y is going to be median. Okay, X is index. Okay, and then of the following is just the plotting property configuration, etc., like the color, label, etc., title, etc., and the legend where you want to put of those, and we already learned, okay. And with this plotting, so here you have the result, etc., popularity over the year, etc. So x-axis is regarding year, and the y-axis is regarding popularity, etc. And we can see that the popularity has some trend. It looks like recent years it's going up, that the trend is going up, okay. And you can also see the medium one is more smooth. Is it not like mean over here you have some uptick, suddenly uptick a lot, is it? So the median is more smooth, but it still shows the upgrowing trend, is it? Because it's not like the downtick, it's uptick, okay. So anyway, so here it gives us some idea about the popularity versus year, is it? So we see the trend is upward, is it upward, and it peaks in 2015, because that's the latest data, this data set collected, is it? And the author concludes based on the author's investigation, research, is it? And said it's reasonable because of the trend going up, is it because of easy access of movie, is it? Why is that? Because of the internet, it's helps a lot in spreading out of the movies information, etc. So that's why, okay. So it's not a surprise. And then what is the second question the author want to find out is regarding the distribution of popularity. Here, be careful, okay, in different revenue level, but only with recent 5 years, okay. And why we want only recent 5 years? Just think about the data starting at what? 1960, is it, to 2015, is it? So it's kind of over 55 years of spans. But think about revenue. Is it revenue, then the money, of course, when you produce money back in 1960, it won't take as much as 2015, even if you think about inflation, is it? So you cannot just see, okay, the revenue or the budget trend, is it? So that's why over here, you want to find different revenue levels, but you use a certain cluster of years, is it? We said, okay, recent 5 years. So that's comparable, is it? Because if you compare 2015 with versus 1960, that's compare with the money level, that doesn't make sense, is it? So that's why only pick the recent 5 years. But regarding different revenue levels, is it? Different revenue levels, and how do we classify the revenue levels? the author said divide the revenue into 5 levels, like low, medium, moderate, and high. Okay, using what? Using the quantile. Okay, and if you recall, the summary report gave us that 25, 50, and 75 quantile, and the minimum and the maximum. Is it with this? And then looks like it matches perfect. So the first 25% quantile going to be low, and the second then going to be what? To be medium. Is it? And then moderate, and then high. Is it? So yeah, so we can use that summary report, also do the multiple levels. Okay, so let's see how do we do that. Because it involves quite a lot of data and the different columns. So if we want to make it more general, the author design a function called cut into quantile. And it's plugged in with a data frame and the column. Okay, the column. And then here, the minimum value going to based on specific column, is it from that data frame's minimum? And then the first quantile based on what? The 25% from the describe. Okay, if you go back to take a look at the describe, you will find that will tell you the information. And the second quantile, the 50% quantile. And then you can pick the specific row. This is a row, is it from the summary result. Then you can get the quantile value and the maximum. Is it? Once you have that, those numbers, then you can put them in a list. Is it? And the list will list the boundary values. Okay, and over here, we also have a list of the names for our bin, as if for our bin. And then you call pandas cut method, if you recall. Then the cut method, if you provide the bin list, is it? And then the data will be cut into these 4 levels, the 4 bins. Okay, 4 bins. And here it says, okay, label is going to be that bin names. Is it? Are you going to include the lowest? It says true. It says true. And over here, you also specify which column you're going to do this kind of cut. Okay. And then you can return this data frame. Okay. So anyway, so this is a quantile function. Okay, and after that, what we can do is we are going to take only look at those recent 5 years. Is it? Okay, so you put those 5 years in a list, and we get our data. Is it? We get our data frame. Okay. And get the data frame, and then over here we use the loop through year by year, that by year. And for our data frame, that we are going to find the data with the specified year. Okay, specified year. And then you're going to get the data for that specific year, going to store in this data frame, is it? And then you're going to call that method, cut into the quantile. Is it based on what? Here you specify, okay, based on revenue with the specific years data frame. Then you're going to append it. We are going to combine all of the data together, is it, for all those 5 years, okay? And then we want to get some glimpse of the data. Okay, so you call the info. And here is some description regarding the data. Okay, and what is the next one? The DFQ2, let's see. Yes, the DFQ2, is it DFQ2 is the data based on year for revenue and already described in different bin level. Is it low or medium or moderate? Is it? And if you recall, you do have this new column. Is it? Revenue level, that new column did get added. Okay. And because of this, then based on that data, we can do group by. Is it group by what? Release year and revenue levels. Is it? And aggregate with what? With median values. Then we take a look at the last 8 records. Is it? And here we get the result. It looks something like this. Is that you group by release year and revenue level. Revenue level, we have low, medium, high, and or moderate and high. Is it? And then based on each year. Is it? And if you recall, the 4 levels, it uses that to describe method. Describe method gave us that 25 minimum, 25, 50%, 75% of those. Is it? And then you have revenue levels. Is it? And then we have those, all of those values, media values. Okay, media values. Okay, we have this data. And here it says you can unstack. Unstack is make it wider. Is it make it wider? After that, we can do bar plotting. Is it to have some clear visualization result be displayed? Yeah, so if you do that bar plotting, you can clearly see, is it? This is release year. And here is a popularity. Is it popularity? Let's double check. Yeah, it's popularity. Okay. So it's regarding, this is popularity. Popularity, is it? And each bar is regarding the revenue level. Okay, so this is revenue level. Is it different color? And you can clearly kind of see in recent, like 2015, is it the popularity correlate with what? With the revenue. Is it? Because this red means the high, so the revenue is very high. So revenue is high, the popularity is also high. The revenue is low, then popularity is also low. And starting from 2011, it all gave this kind of trend. Is it? So revenue level correlates with popularity. We can kind of see this trend. Is it? Okay. And this part, it's just you can do different kind of bar plotting. So this is customized bar plotting. Okay, because sometimes if you use the provided one from the package, it may not meet your, if you write some report result for the visualization. In that case, then you can do your customized plotting. So this part show us how to do customized plotting. Okay. On the on the customized, okay, and we can tomorrow probably we can get back to the customized design. So next, let's take a look the release year and the revenue levels, okay. So group by release year and the revenue levels, we already saw this, and oh, this time we do mean, okay, we do mean, and then what we do is we also do revenue and stack, etc. And then we also do the bar plotting, etc. And for the bar plotting, it give us this kind of result, etc. And this is based on revenue, not budget, etc. And it's kind of similar. It's revenue high, then popularity also high. Okay, also high. So kind of a similar trend. And then what the next one show is regarding the vote average. So does vote average has some also rely on revenue levels, is it? And we can also see, so the plotting shows is this. Okay, so high revenue and low revenue. This is voting average. So it's pretty close, is it? It's pretty close. So it looks like voting average doesn't depends on the revenue a lot, is it? So that's kind of the trend we can have for this very general idea, okay, very general idea. And regarding this customize, and you can kind of see it's prettier as it if you do like executive report, and this probably is better versus the default provided one, is it? So how do we do our own customized plotting? So tomorrow we can discuss that. So today we finish